Hello, hello, and welcome to this video. In this video, we will solve 10 more problems. We had solved till problem number 120. So you will solve till 130, starting from 121 to 130. And I will say what I always say is that when I'm stating the problem, you should pause the video. And only if you cannot solve the problem yourself, then look at the solution. Now, one more thing is that usually I make the subscription request and like request at the end of video, but I'll say that uh, sharing is a good thing. So you should share the video with your friends and you should subscribe to the channel if you have not subscribed yet and like the video. So there are two reasons why I asked for this is one is that YouTube algorithm will show the recommendation into more places if likes are more and if share is more, then the sharing is always there. If you subscribe to the channel, even then it will come to your feed. New videos will come to your feed. So the reach of videos effectively increases a lot. The second thing is that if you subscribe to the channel and like the video, then it motivates me to make more such videos. Because if you see this PDF is 900 pages long roughly. So a lot of effort has gone into making this book. And I would appreciate if you can subscribe and like the channel. That would be like effectively what would be the word is payback, right? So thanks a lot for subscribing and liking the video. So now we start the actual video. Now question 121 says that so that x minus 1 whole square is a factor of x to the power n plus 1 minus x to the power n minus x plus 1. So it is a very easy one. We can write the given expression as x to the power m minus 1 into x minus 1. And x to the power m minus 1, we can write as x to the power m minus 1 plus x to the power m minus 2 and so on up to x square plus x plus 1. And then the factor x minus 1 is taken out, so it becomes x minus 1 whole square. And therefore, x minus 1 whole square is a factor of this given expression. Question 122 says that find all real solution x of the equation x to the power 10 minus x to the power 8 plus 8x to the power 6 minus 24x to the power 4 plus 32x square minus 48. So we look at the solution. So what we do is we take out x square minus 2 common. Okay. So once we take out that, what remains inside is x to the power 8 plus x to the power 6 plus 10x to the power 4 minus 4x square plus 24, which is 0. Now, if x square minus 2 is 0, then x is equal to plus minus the square root of 2. Now, if you look at the remaining equation, that is x to the power 8 plus x to the power 6 plus 10x to the power 4 minus 4x square plus 24. So, what we do is we rewrite this. We write as x to the power 8 plus x to the power 6 plus 9x4 plus x to the power 4 minus 4x square plus 4 plus 20. So this gives us x to the power 8 plus x to the power 6 plus 9x to the power 4 plus x square minus 2 whole square plus 20. Now these are even powers of x. So for all real values, this would be greater than 0. And then we have 20, which is positive, will be greater than 0. And we also have x square minus 2 whole square here, which is again a square, so it would be greater than 0. Thus, the given equation has only two solutions, plus minus square root of 2. Now we move on to question 123. Solve 2x to the power 99 plus 3x to the power 98 plus 2x to the power 97 plus 3x to the power 96 and so on up to 2x plus 3 is equal to 0 in the set of real numbers. So as you can see, the 3's and 2's alternate, okay? And the power x square is increasing. Okay, so 3 it will be followed by 3x square plus 3x to the power 4 plus and so on. So it goes up to 98. And 2 starts with the terms which are multiple of 2 starts with 2x, then 2x cubed, then 2x5, it goes on up to 99. So our first term for the term containing 3 is 3, and then we apply the geometric series summation. We get x to the power 100 minus 1 by x squared minus 1. And the second term would be 2x into x to the power 100 minus 1 by x squared minus 1 is equal to 0. Now, this implies that x squared is, 3 plus 2x is equal to 0. The reason is x is not equal to 1. How can we say that x is not equal to 1? If you substitute x is equal to 1, then all terms are positive and they will either be 2 or 3. So half the term will be 2, half of the term will be 3. So you will have 49 to 90, that is 98, and then you have 53. So 150, the sum would be 240, which will be not equal to 0. So straight up you can see that since the quotients are all positive, the solution won't be 1. So what this means is this term x to the power 100 minus 1 by x squared minus 1 won't be 0. That essentially implies that 3 plus 2x is equal to 0, so x is equal to minus 3 by 2. Now we solve question number 124. It asks us to prove 1 plus x to the power 111 plus x to the power 222 plus x to the power 333 plus x to the power 444 divides 1 plus x to the power 111 plus x to the power 222 up to x to the power 999. So what we do in this case is like the previous problem, we sum the expressions. So for the denominator, it comes out as x to the power 555 minus 1 by x to the power 111 minus 1. And for the numerator, it comes as x to the power 1110 minus 1 by x to the power 111 minus 1. That is straight up sum formula for geometric progression. Now we see that x to the power 10 is equal to x to the power 2 into pi 55. So we can write it as a product of x to the power 555 minus 1 and x to the power 555 plus 1. So now the denominators of the sums are same, so they will divide. And we have proven that numerator of the numerator of the denominator in the actual division is now a factor of x to the power 555 minus 1. So the required condition is fulfilled. Question 125 says that if x, y, z are rational and strictly positive, and if 1 by x plus 1 by y is equal to 1 by z, show that the square root of x square plus y square plus z square is rational. So we are given that 1 plus x plus 1 by y is equal to 1 by z. That implies that we simplify this. This will become x plus y by xy is equal to 1 by z. So zx plus yz minus xy is equal to 0. Now we look at the value of x plus y minus z whole square, that is x square plus y square plus z square minus zx minus yz plus xy. Now this means that these terms, that is zx, yz and xy, will become 0. So x plus y minus z whole square is equal to x square plus y square plus z square, and therefore the square root of x square plus y square plus z square is equal to plus minus x plus y minus z, which is rational because our given x, y, z are rational and strictly positive. Now we go to question 126. It says that if a square x cube plus b square y cube plus c square z cube is equal to 3 to the power 5, x square is equal to by square is equal to cz square, and 1 by x plus 1 by y plus 1 by z is equal to 1 by p. Then we have to find square root of a plus square root of b plus square root of c only in terms of p. That is, we have to eliminate x, y, and z. So we are given 3 equations and we have 3 unknowns, so it is definitely possible. So it is given that x square plus by square plus cz square is equal to k, and we are given that a square x cube plus b square y cube plus c square z cube, so is equal to 3 to the power 5. So if you look at the value of a square, it will be a square x to the power 4, b square y to the power 4, c square z to the power 4. So the given equality, which is over here, can be written as k square plus x plus k square by y plus k square by z, which is equal to p to the power 5. But we are given that 1 plus x plus 1, 1 plus x plus 1 plus y plus 1 by z is equal to 1 by t. So what happens is 1 by t is now becomes equal to p to the power 5 by k square. That means k is equal to p to the power 3. Once we have the k, it is trivial to solve for square root of a plus square root of b plus square root of c, because now this will be k by x square, k by y square, k by z square. So what we do is we substitute square root of p cube. Okay. So if you look at this term, if you take square of this, it becomes square root of a x. So square root of a is square root of k by x. So that means the square root of p cube by x, because k is p cube, is square root of a and so on, and therefore we have the sum, and then we take out the square root of p cube, and the remainder which we have is 1 plus x plus 1 plus y plus 1 plus z, which is equal to p, and therefore the sum is square root of p. Now we move on to question 127. It says that if x cube is equal to by cube is equal to cz cube and 1 plus x plus 1 plus y plus 1 by z, sorry, I misread that, 1 by x plus 1 by y plus 1 by z is equal to 1, prove that cube root of x square plus by square plus cz square is equal to cube root of a plus cube root of b plus cube root of c. So we are given that x cube is equal to by cube is equal to cz cube is equal to k. So x square would be k by x, by square would be k by y, and cz square would be k by z. So our left hand side, we look at our left hand side, and then we see that it is equal to cube root of 1 k by x plus k by y plus k by z. Now, since we are given that 1 by x plus 1 by y plus 1 by z is 1, so this value is cube root of k. So now we have this is equal to cube root of k. Okay. Now, if you see this, okay, if you see this cube root of k, so we can write this as cube root of k into 1 by x plus 1 by y plus 1 by z. Okay, and then it is directly equal to cube root of a plus cube root of b plus cube root of c. So how do you solve this? Is you bring x over here, it becomes k by x cube. So then you take cube root of left hand side and right hand side. So a will become cube root of a, and k by x cube will become cube root of k by x. That is how this last equality is derived. Now we look at question number 28. Prove that if x, y, z is a solution of the system of equations x plus y plus z is equal to a, 1 by x plus 1 by y plus 1 by z is equal to a, then at least one of the numbers x, y, z is a. So this is fairly straightforward problem. So we are given that x plus y plus z is equal to a, and 1 by x plus 1 by y plus 1 by z is equal to 1 by a. So what we can say is 1 by x plus 1 by y plus 1 by z is equal to 1 by x plus y plus z. So if you simplify this, you will get x plus y into y plus z into z plus x is equal to 0. So at least one of the terms is 0 on this, in this side, okay? Either x plus y is 0, y plus z, or z plus x. One of them has to be 0. Once one of them is 0, you can put that value in this equation, and automatically it will make the third value a. So we now move on to question 129. If one root of the equation to x square minus 6x plus k is equal to 0 is 1 by 2a plus 5i, where I square is equal to minus 1, that is iota of complex number, k and a belong to the set of real number, then we have to find the value of a and k. Right? So this is a very straightforward problem. Since ak of the equation are both in the set of real numbers, the other root, the roots will be complex conjugate pair, and therefore the sum of the second root will automatically become half into a minus 5i, and then the sum of root will be a is equal to 3. So the sum of roots would be a, and this minus b by 2a, that is 6 by 2 is 3, and therefore a is 3, and product of roots would be a by 2, which will be equal to 1 by 4 a square plus 5 square. Now a is 3, so that becomes 9, and 5 square is 25, so 34, and this 2 goes here, it's here 2, so 17, a is equal to 17. Now we come to the last question of this set. We have if x cube plus bx square plus p is equal to 0, where p is not equal to 0, has a root of multiplicity 2. Prove that 40 cube plus 27p is equal to 0. Now by multiplicity, we mean that a root repeats. Okay? So there will be 3 roots of this equation, and one of the roots would be repeated. So we look at the solution. So let's say the roots are a, b. So because a has multiplicity 2 here, it appears twice. So from Newton's relationship, we can write 2a plus b is equal to minus 3, a square plus 2ab is equal to 0, and a is equal to minus 2b, and a square b is equal to minus q. We have to prove that 40 cube is plus 27p is equal to 0, and we have obtained p is equal to 2a plus b, so we substitute it here. This is minus p. So this would be minus 4 into 2a plus b whole cube minus 27 a square b, because q is a square b minus a square b. That is equal to 0. That implies that minus 4 into minus 3b, because our a is equal to minus 2b, so this becomes minus 3b. So we have minus 3b whole cube here. So 27 for 118, no, 108, 27 for 108. So 108 b cube, and then over here we have 27 into 4 again, and that is also b cube. So both of that becomes 108 b cube, and the end result is 0, and that's how we have proven that 4b cube plus 27 cube is equal to 0. So I hope that you have enjoyed this video and found this useful and informative. I would suggest to focus on your studies and do not waste time, because as we say, time is money, but time is also knowledge, because you can spend time to get knowledge. Time is said money because you can spend time to make money, but at the same time, you can spend time to get knowledge. And then when you have knowledge, you can spend knowledge and time to get money. And if you have money and knowledge, you can spend both of them to make time. So the 3 are related. You can spend 2 to get the third. So again, thanks a lot for watching. Enjoy.